We have some slides, but we mostly have hands-on tutorials. These are the topics we are hoping to cover. They are a subset of topics from a much bigger set of training modules that you have, which is on that website that you might have visited by now. What Dennis and I were thinking of doing. So my name is Vani Mandava. You can I'm on the agenda. I work for Microsoft Research. Dennis Gannon is my co-presenter. He is his official affiliation is Indiana University, and he's really very distinguished in this field of cloud computing and data science. And I'm honored to present with him today. So we may not have time to have you work through every single one of these modules. So what we were thinking of doing was, go through the introduction, make sure you're able to activate the Azure Pass, which is an Azure subscription with $500 worth of credits that is valid for a month. So you can continue playing with it after today. I'll just quickly walk through the Azure Blob Storage, what are the different options available there. We will not do the storage lab, it's too simple. But we will spend the rest of the time on the container services module and either Spark or machine learning you can pick. And because there's so few of us in this room, I'm happy to just walk around and help if anyone is stuck or something. It's all very detailed. The documentation is fairly detailed, and but there is a little bit of going back and forth between the portal and the instructions and so on. So with that, the first thing I would ask you to do is go to that link aka.ms/learncloud, and if those headers are not hyperlinks for you, it means that you need to sign in. There is a sign in on the top right of that of that web page. So just sign in using any account that is registered with Microsoft. It doesn't have to be a Hotmail or Outlook. It can be a Gmail or your EDU account. But once you sign in, those links will light up, and that should give you access to the modules. That's what it looks like once you're signed in. And the first module that you'll be doing in order to activate your Azure Pass is the first one here using the Azure portal. And just so you know, what we'll be doing today is just scratching the surface of Azure. There's a lot on Azure. If you just look at, the Azure documentation, I'm going to quickly show you where the different modules are, especially the ones that relate to data and analytics. If you go to documentation and you look at the different services, you can see here on the left, under data and analytics, there are all these. The ones we'll be covering today are under HDInsight and machine learning, but there's several others that is very cleanly documented, and there's some really good, tutorials and hands-on labs even over here. Sure, yeah. I'll switch back to. Yeah, so when working through that lab, it's important that you start a new incognito window because otherwise it's going to try and pick up credentials from, if you have any other Azure Pass or in general, if you've logged into any other Microsoft properties, it's going to try and pick up credentials from there. Right. So what this exercise has you do is request an Azure Pass by submitting your email address. But when that Azure Pass is made available to you, you will get a new email ID and password that you can use. So that way, it doesn't get mixed up with any previous subscriptions that you had. It's better to do it that way. That way, you start with a clean and blank subscription. But once you submit your request for an Azure Pass, we have to approve the request. So either Dennis or I can do that, and then that pass becomes available to you in the same browser window. And that URL where you'll be requesting the pass is azureforresearch.org. And one thing that you should know is that this web page that you see, the aka.mslearncloud, this page that you first navigated to, is just a nice web interface on top of the training content that's in GitHub. The GitHub link is in the header of that web page. So I know 2 students in the class had problems with this web page itself. Feel free to just go directly to the GitHub repository and open the modules from there. So the specific modules are introduction. That's the one that we're walking through right now. And then the others that we'll be looking at are machine learning, and then Spark inside the HDInsight folder. And there's a different module for container services that Dennis will walk you through. I'm going to talk a little bit about storage while I think there's a couple more students who are still trying to activate the Azure Pass. I'll talk about storage. If you want, you can dive straight into the storage lab, but we're not really going to walk through that today since it takes about 30-45 minutes to do, and it's really simple. You can do that later on your own time. And another thing, it would be useful in the future to also download the zip from the GitHub repository. There's one lab that requires access to some resources that are in the zip file, contained in the zip file. You can do that now, or you can do that later when you're working through the lab. So that's the module that we just did, activating an Azure Pass. I'm going to talk a little bit about Azure Storage. So Azure Storage gives you access to 4 different kinds of data. So Azure Blobs, which is the most common way of using Azure Storage. Azure Queues, which is a good messaging and workflow type of storage. And Azure Tables, which is now subsumed within Cosmos DB for NoSQL type of storage. Cosmos DB is sort of the latest and greatest release in the NoSQL space from Azure, and it's very useful for extremely low latency, globally distributed databases. And then Azure Files, which is if you have legacy applications that require SMB type of access, if you just wanted to mount a drive, then you use Azure Files. It's mostly for enterprise legacy applications. The most common usage in researchers and scientific data is typically through Azure Blobs, where you can have up to 4.75 terabytes of data in an individual blob. And this is the hierarchy of what an Azure Blob is like. There is account, and then within accounts there are Azure containers, and within Azure containers there are Azure Blobs. That's what an Azure Blob URL looks like, where the first part of the URL is the account itself, and then .blob.core.windows.net is the fixed part of the URL. Images, which is here, is the container name, and the blob name itself is schema.jpg in this case. In an individual Azure Storage account, you can have up to 500 terabytes of data, and you can have up to 200 storage accounts per subscription. So the storage account, the subscription that you got today, could technically have up to 200 storage accounts. And then there are 4 types of replication: locally redundant, zone redundant, geo-replicated redundant. And depending on which storage schema you choose, there's multiple copies of your data. So for zone redundant storage, your data is replicated 3 times across 2 to 3 facilities, either within a single region or across 2 regions. And geo-redundant storage is enabled for your storage account by default when you create it, and it maintains 6 copies of your data. With geo-redundant storage, your data is replicated 3 times within the primary region and is also replicated 3 times in a secondary region. And there's a slight difference in cost, obviously, depending on which redundant scheme you choose. The last one, read access geo-redundant storage, will replicate your data to a secondary geographic location, and it also provides read access to your data in the secondary location. And then finally, you get 2 access keys by default when you create a storage account. Obviously, you have to keep these very securely. And you can use these access keys to generate shared access signatures in order to give data access to your data through your applications. That's what a shared access signature looks like. That's the query string to the blob with the shared access signature appended to it. It is digitally signed, so Azure will reject a modified shared access signature. By default, there are 3 access policies: private, container, and blob. So the main difference between making a container public versus making a blob public is that in the container, the contents of the container can be enumerated once it's public. And then another important, there's a free cross-platform client-side tool for managing your Azure Storage account. It's called Azure Storage Explorer. There's a lot of capabilities available in the browser itself through the Azure portal for managing your storage account. But if you're okay installing a client-side tool, I would highly recommend installing Azure Storage Explorer. So the lab that corresponds to learning how to use Azure Blob Storage and how to create shared access signature access to your data is 101 in the list of modules, which is using Azure Blob Storage. Feel free to do that lab, but probably not right now, because then we won't get time to do some of the other stuff like container services and Spark. What you could do right now is maybe just like crack open that lab and go through the screens and see, what the steps are.
Now, how many people here have already used, say, Docker before? Raise your hand if you've used Docker. Okay, that's about a quarter of you. All right, so I'm going to start off with a little bit of introduction to containers, and then we'll go into the whole idea behind Kubernetes and clusters of containers, and you get an idea about that. First of all, the whole idea of containers, since most of you haven't used them before, is that it had to do with the problem of deploying software. And a lot of people, people that have had any experience with using machines and trying to deploy software, there's a big challenge in getting different applications to work together with different environments and different requirements, different core operating systems. And this is a terrible problem. Well, recently, I guess probably in the last 7-8 years, people have discovered that with Linux, there's some really important parts of the kernel that allow you to encapsulate entire applications into containerized pieces. These applications run as a complete instance of an operating system together with all the libraries and modules that you need and your application. So you package your application into what's called a container. Now that container then can run as a process on Linux, or if you know what you're doing, on Windows, and or actually run very well on Windows and Linux and on the Mac without change. The same application code wrapped with all of its libraries, all of its dependencies, its core operating system runs on top of basically any machine you can find now without change. And this is not the same as a virtual machine. A virtual machine is a much more heavyweight system. A container runs as a process on the machine. And so you can get a lot of containers onto one machine. So to give you an idea what that looks like, is Docker is the main, there's like 4 or 5 different container systems. And something called Docker is the main container system. And it works, it's very nice. It's very easy to install. If you have a Mac, it's easy to install Docker. You don't need to do that for this project here, but it's trivial to do it. You could do it over a coffee break. Install the Docker system on your Mac or your PC or your Linux box without any problems. And then once you have Docker system installed, then you can, there's something called the Docker Hub. The Docker Hub has a repository of thousands of containerized applications that people have already built and tested, and you can tell which ones are good because by the number of times they've been downloaded. So you go to the Docker Hub and you can find great stuff. And now to illustrate how easy it is, what I'm gonna do, how many are familiar with WordPress, the blogging system? Yeah, most everybody knows WordPress. Okay, I have a blog on WordPress and I rely on the WordPress company to take care of it. But if you want to install your own version of the entire WordPress system, if you try to do it yourself, well, you need a MySQL database, so you got to install the MySQL database, then you have to do all the stuff involved with getting the whole WordPress site downloaded and uploaded and installed and running and then talking to your database. That could take you a day. If you're like me, if you're really good, it might take you half a day to do it. Or if you already have a MySQL installed, well, that's not too bad either. But I can do it in 2 command lines with Docker. And so on the slide, you see there's 2 Docker commands, Docker run with a name and a password, and that sets up a MySQL database. And then the second command at the bottom of the slide says Docker run with a link to MySQL database, WordPress. And doing that, it comes up practically. It takes to download the core components, it takes a few seconds for it to download those pieces from the Docker Hub, but you just sit there and watch. And then once it's done, you can tell, oh, it just started. And then you go to 8080 and this is what I did in a few minutes. I created my own Docker or my own WordPress installation and created a blog. I did everything I wanted. It was all there. It ran. And I think that's a very powerful thing. Now, one of the things this is related to is something called microservices. And what the people in the cloud business have discovered is that running big, massive applications that are supposed to be used by thousands and thousands of people simultaneously across many continents is really hard. And so people started to realize in order to make this work, you have to have something that's easy to maintain, that's easy to assemble, and so you partition big applications into very small pieces. And these pieces communicate with each other over standard protocols, and so you can update and repair a part of an application very quickly by just replacing certain pieces. And it's an enormously powerful thing. And so what you find is that, Netflix, all of Netflix works on this principle, breaking their application, Netflix application, into many thousands of tiny components distributed over their data centers. That is the Netflix application that manages everything for them. Google Docs is the same way. All of the Azure services are the same way. eBay, Amazon, most of their services are that way. The UK government digital services, Twitter's all this way. Basically, everybody is doing it this way because it's one way to build massive systems that operate at scale. Okay, so and these are typically run as containers, and very often they're Docker containers. And so what happens is you have a bunch of services, cores over there on the right, and you begin by breaking your application into a few components. The next thing you do is you bring the you can bring on more components later without breaking down the others. And then I could say, okay, now let's add some more pieces to that. And then eventually I could get rid of pieces I don't want. And so this incremental upgrade by installing and deleting containers is very easy. Now, what we're going to do is we're going to go through and we're going to install Kubernetes. Now, Kubernetes is something that is released open source by Google. They have been using it internally for all their systems for years. And they said, oh, might as well let everybody else use it too. And so now we have it on Azure, and Amazon has it too. And it's based on the idea of machines, and you put containers on machines, but containers are contained in pods. Now, we're not going to use pods very much today at all, really, in this example, but it's a way of grouping related containers together. Now, we're going to do this using something called the Azure command line interface. And I'm wondering how many people have the command line interface installed, either on your Mac or your PC. One, good, somebody does. Is it version 2.0? We'll Okay, well, we're going to go through that too. All right, so we're going to do installing Kubernetes, and we're going to go through an example. Now, if you go to the link on this page, and this is the hands-on part, so it's http://aka.ms/kddacs. And if you go to that page, let's see here. I got to get to the... Oops. Well, let me go to that page. Uh-oh, sorry about that. It is HTTP okay, you should see this. Deploy Kubernetes cluster for Linux containers. So we're going to be deploying Linux containers on Azure. So Microsoft is not just Windows anymore. Okay, now, and it's going to be a little application. It has two pieces. One will be a database, and the other piece will be a little web page. Now, to do this thing, if you go down on the page a bit, you're going to need to either to do this, there's a couple of ways to do it. You could either, if you go to the main, your Azure portal page, you can create something at the bottom of your Azure portal page, which is called the Azure command line. Or you could install the command line directly on your machine. So there's a link here, install Azure CLI 2.0. And so if you go to that link, you'll get the instructions for that. But first, it's worth going to have you all got to your Azure dashboard yet? Okay, if you've seen the Azure dashboard, how many people have seen the Azure dashboard so far? Okay, not everybody. You have trouble seeing the Azure. The Azure portal. So everybody but one has got the Azure. You have the Azure portal yet, or yeah? Okay. Now, if you look at the very upper right corner of the Azure, or the top bar in the Azure portal, you should see a magnifying glass, and then a little alarm bell, and then something that looks like a command prompt. It's got an arrow with an underscore underneath it. Click on that. And if you click on that, you will see that you now have a command line interface. And you can expand that so that it covers the whole display if you want. Using that command line, you can go through the steps in this application. Otherwise, you can install the command line interface on your machine. So I'll let you follow the instructions there, because this is supposed to be hands-on, and we'll walk around and see where you're getting stuck and where it's hard.
Okay, so what we're just gonna move on to another topic, and then we'll come back and revisit the container stuff if you're able to figure out what the issue with the resource group creation is. There's two labs that you could potentially do: the machine learning lab or the Spark lab. I'll go over a quick overview of what the HDInsight capabilities of Azure are. So basically, Hadoop is available on Azure under the name of HDInsight. It uses HDFS for storage, and it includes Hive, Big, Storm for streaming data, Spark, and it also includes some of the BI tools versus ODBC connectors such as Power BI, Excel, SSRS, Tableau, and so on. So the cluster types in HDInsight, what Azure allows you to do is easily deploy multi-node HDInsight cluster, and the types of cluster that are available in this are Hadoop, HBase, Storm, and Spark. The Spark core, which is the lab that we're going to do today, includes pre-installed with its Spark SQL, Spark Streaming, GraphX, and MLlib, and also Jupyter notebooks and Anaconda notebooks, and the drivers for the BI tools. The lab that we do today will have you work through some examples using Jupyter notebooks on HDInsight. What Jupyter Notebooks does. How many of you have used Jupyter Notebooks already? Awesome. Okay. I'm sure you know that it provides a browser-based development environment for working with, all sorts of cool visualizations and text and code and so on. And the one important piece you have to remember here is that these tend to consume resources pretty fast, and your build keeps running, so you have to delete your HDInsight cluster once you're done working with it. There is no suspend mode for HDInsight clusters, unlike VMs. If you just spin up virtual machines, you can suspend them and you can come back and restart them. That ability does not exist for HDInsight, so you have to delete the cluster. Your data is in your storage account, it's separate, so it does not get affected when you delete your cluster. You should be okay doing that. You just have to spend the 10 minutes the next time you want to spin up the cluster again. So that is HDInsight. And then what I'd like you to do now is go back to the labs that you had on that first page that you were looking at. There is a lab in there for Spark HDInsight. Go ahead and start the deployment for a Spark cluster because it will take about 10-15 minutes to deploy. Once you get that started, we can come back to the Azure Machine Learning. I'll walk through a few slides, and then, by then the Spark cluster would be deployed, and you can either run through the Spark lab or you can do the Machine Learning lab. So that particular lab is 302A, Data Analytics with Apache Spark for Azure HDInsight. And the specific step that I'm talking about is in Azure Portal, you go New Data Analytics, HDInsight, and follow the instructions to create Spark. There's a cluster type drop down there where you'll select Spark, and you can walk through the instructions. If you are not using the website and if you're using GitHub directly, the specific training module is available under the HDInsight folder, HDInsight Spark, and it's the same. So you can either look through the web page where you have the page-by-page instructions, or you can get the instructions directly from GitHub.